Welcome back everyone, my name is Dustin. In the last video, we actually got the collisions working correctly and getting the lives to work, also some projectiles. In this video, we're going to work on the HUD or heads up display and getting the ship to explode. That's the goal for this episode. I'm going to try to finish the Asteroids game in this episode, so it might be a little bit longer. Alright, so let's get started. Let's go to the game-data.lua file, and that is game-data.lua. So we already have the score here. We need to actually add some functionality. So let's go add to score. So we'll go function, and we go game data, add to score, and we'll send in a value. Okay. And then from here, we're just going to write self.mScore is equal to clamp. I decided the max score is going to be 99,999. So it's 5 digits. So it will be self.mScore plus value, and we'll clamp that to 0 and 99999. Cool, that's it for that one. And then we'll do another one for getScore, function, game data, getScore, and that is just return m_score, self.mScore. We want to return that, sorry, return. Cool. While we're here, we might as well add something in, a function to reset everything back to their default values. So say we get to a game over state and we want to restart it. Well, we want to restart it and reset everything back. So let's go function, game data, reset. And we'll say self.m_num_asteroids is equal to 0. That's if we want to keep track of the asteroids. Num lives is equal to 3. And score is equal to 0. And all right. So let's actually put a few constants in here for our score. So we'll just say constants. They're not really constants. You can change their values, but we'll put them here and make them act like constants. And it'll just be small asteroid score. And the small asteroid will just be 15. And we'll have the large asteroid equal to 100. Large asteroid. Cool. All right, so now that we can add in a score, let's go back to our utilities.lua and add that in. It was right here. Oh, wait, not there, sorry. Right here, to do add score. So we have our G data, add to score. And this is the big one, so we want to send in the large asteroid score. And we'll copy this here for small, and then make this the small asteroids score. So small asteroid score. Awesome. So let's go back into our main, get rid of the lives here, and just put score. And we'll change this to get score and see if that's working. If we hit anything, bang, there we go. All right, our score is going up. Those are pretty fast moving. Perfect, that's exactly what I wanted to see. And we got hit, that's all right. Awesome, so you see our scores going up over here. That's what we want. All right, so now that we have our score updating, it's time to create the HUD class. The HUD is going to need the score, the current lives, and the lives entities. And what I mean about lives entities is that instead of a number, I want to use the ship sprite for each of the lives that we have. And we're going to have a max number of 5 lives. Since the engine does not support text yet, we also need to create entities that will display the score for us. So they'll also have a sprite, okay? So let's take a look at those now. So we're going to use this little ship entity here, or this little ship texture for our lives. And I got this from the same asset pack. And then we're going to use these numbers here. I created these numbers from other numbers, and we're going to use these for our score. From the same asset pack, I grabbed these so I could write game over. I just made this up, and I made this one for score as well. All right, so let's go back into and create the HUD. Okay, so here, let's go into our asteroid, scripts, asteroids, and let's add in a new file. New file, that's going to be hud.lua. hud.lua, And just like always, we're going to say HUD is equal to our namespace. HUD index is equal to HUD. And then we're going to create the HUD. So function HUD create. It's not going to have any parameters. Everything's going to be done inside. And we're going to say local this. And then we're going to have a few things. First thing we're going to have is a table of entities for the lives. And we'll just call that M lives. And that's just equal to an empty table. And then we're going to have the current lives. So M current lives is equal to G data max lives. And M score is equal to 0. Now the reason why I'm setting this to max lives here is because I want to have 5 sprites. Okay, so before we can continue here, we're going to be creating entities for our lives, score, game over, everything. We're going to be creating entities for that. So the best thing for us to do here is to create some definition. So let's go create a new table and call it HUD defs. And we'll do that in our entity defs. And we'll just put that down here. So we'll say HUD defs is equal to a new table. And the first one we're going to do is lives. So lives is equal to a new table. And we're going to say group is equal to lives. Components is equal to a new table. We're going to have transform and sprite, so we can just copy these here. And these can just default just like that. And we're going to have a new asset name that we call lives. And this one is 48 by 48. That's that little ship I showed you guys earlier. And we're going to just put this to layer 10. So we know that it's high, it's the HUD, all right? And then we're going to want to create the score. So basically we copy all this here for lives, copy this for score, change the lives to score. And this one will have a tag, and that's going to be score. And the components are going to basically be the same, but this one, I know exactly where I want to put it because I've already messed around with it. We can change the spot if we need, but it's going to be at 0y and 200x. And this one's going to be 4 by 4 for scale. I want to scale this up a little bit. And our asset name is going to be score. And this one's 48 by 16. 48 by 16, 0. Okay, and that's 0, 0, layer 10, perfect. So here in score, and it's 48 by 16. And we'll copy this again and create the numbers. Change this to numbers, or just number. And this one will have a group numbers. Components. We're going to start these at 380. And then we'll offset them from there. And then this will be numbers. And the width of each number is 16 by 16. Start 0 and layer 10. Perfect. So that should be good for our HUD defs. Let's go back to the HUD. Okay, so now we actually want to load in our lives entity. So we want to loop through the max lives and create a new lives entity and change its transform based on its positions. We have a default position and then we want to move it over based on the width of the sprite times the current lives that it is. So we go for I equals 0, G data max lives. Do, let's say -1, and here we want to create a local lives ID is load entity, and we're sending in the HUD defs, and we want to get the lives. So that should load our entity for us and send us back the ID. Then we want to say local lives entity is equal to entity lives ID. And then from there, we want to grab the transform. Local transform is equal to lives entity. Too many T's. Let's fix that. Entity You guys probably saw that already. And then get component, transform component. And now we want to adjust our transform according to its default position plus 48 times I. So we'll say transform, because 48 is the width of this, of each sprite, dot position is equal to vec2 48, so that's the width. Now we could put it in a hard-coded value. We could actually get the width of the sprite, but we'll just do this for now. Times I and 0. And then we want to insert our lives into the table. So we just have this new one, so we go table dot insert, and that's this dot m lives. And we want to insert our new lives ID. We're just inserting the ID into this table. That's all we need. So that gives us, so let's say create our lives entities. Cool. So now we want to set our score entity data. First thing we'll do is the actual score tag itself, or the scorer name, or score header, whatever you want to call it. So let's say score entity data, and we'll say this dot m score, let's say ID, score ID, is equal to load entity HUD defs at score. Then we wanted to start going through our score. So if you think about it, we have 9, 9, 9, 9, 9. So the first one's going to be 10,000, thousands, hundreds, tens, and ones. Okay? So that's what we're going to need here. So we'll go this dot m 10,000 ID is equal to load entity HUD defs, and this is just the number. All the numbers for the score will have the same def, so we can just 1, 2, 3, 5. That's we need 5, and we just change this accordingly. So instead of 10,000, it's just 1,000. Change this to 100. Change this to tens. Tens ID, and change this to ones. Whoops. Okay, so we have all those entities, and now we want to set the game over entity data. So we'll go game over entity data, and we'll start with this dot mb game over is equal to false, because it's not going to start as game over. This dot mb show game over, because we don't always want to show it, and that's also equal to false. And then we're going to get the game over entity itself. Dot game over ID is equal to load entity. And this one, we need to actually add that in, and we didn't add that in. So let's go back to our HUD table, or our HUD definition, sorry, and that's in our entity defs. And we need to add in the game over, and we can just put that here. Actually, we just copy this. Change this from number to game over. Game over. This could have a tag. Game over. And we're going to have this start at kind of like the middle of the screen. So let's say x is equal to window width divided by 2. So in the middle of the screen. And the game over, so we have the width, then we have to subtract half of the size of the game over. So let's go see what that is. Over here, game over, and let's see. So the width is 80 pixels. So we go back here, but I also want to set my scale a little bit larger. So it's 80 times 6 divided by 2. So 8 times 6 is 48, divided by 2 is 240. Cool. And we want to do the same thing for height. So window height divided by 2. And we want to minus, was the height of that? I think it was 16. So let's go back. The height of that, yep, 16 times 6 is 96, divided by 2 is 48. Okay. Minus 48. Cool, that should put it in the center of the screen for us. Rotation 0, and a width of this is 80. And 16, sorry, leave that. And this is actually called, we're going to call this game over. Start 0, and now we need to add in a new variable. And it's going to be, for the sprite, it's going to be B hidden. And it's going to be hidden off the bat. Now, we don't have this hidden variable in our sprite, so we're going to have to add that in. So let's go do that now. So let's go to our sprite component in our ECS component. Sprite component is here, and we're going to have to add in our hidden. So what I want the hidden for is, so say the entity is alive and it's there, but we don't want it to show. We want to just put in a flag to say that this is hidden. Don't add this to our batch, to our sprite batch. So we go bool b hidden, and that'll just default as false. So we add that there, and now we have to just go add it to our bind. So we go here, and down where it says right before color, let's just copy this line, change this to be hidden, and change this to be hidden. Cool. So now that's in our sprite component. Now we got to go to our render system and add that in. So let's go to our render system here. And the same way that right here where we're skipping, we're not going to add it to our batch or add a sprite here if there's no texture. We also don't want to add it if it's hidden. So we go sprite.be hidden. Cool, and that will skip that particular sprite. All right, so let's go back to our HUD.lua, and we can load the HUD defs here, and that's at game over. Awesome. So don't forget, we got to set meta table. Meta table. I always think I mess that up. There's a lot of T's in there. This and self. And then we're going to want to return this. Return this. Cool. So now we're going to have to add a few functions. We want to be able to update the HUD. So let's just add that in first. So function HUD. And then we'll put some stuff in there and we'll go from there. So update. So we're going to update the HUD. Okay. And inside of here, we're going to want to check this to see if it's game over. And if it's not game over, we're going to update our lives and update our score. So go if not self dot m be game over. Then we're going to have two functions in here. One is going to be self dot update lives. Another one's going to be self update score. Okay. And then we don't want to finish there. So then we want to say else if. Let's bring this down and make this a bit bigger. Maybe too big. Okay. Else if not self.m be show game over. Then here we actually want to show the game over sprite. So if we are game over, but this isn't showing, now we want to set it to being shown. Okay, so we say local entity is equal to entity self.m game over ID. So that'll get us our entity. And we want to say local sprite is equal to entity get component sprite component. Then we say sprite dot be hidden is equal to false. We don't want it to be hidden anymore. We actually want it to show. Then we say self dot mb show game over is equal to false or is equal to true. Sorry. So we're showing game over right now. Okay. Does that make sense? So right now we don't want to do any of this updating if it's game over. And if it is game over, we want to show our game over, but we don't want to keep showing it over and over again. We don't want to keep changing this data because it's already there. So let's create those other functions right now. So let's go function HUD, and we want to say update lives. Okay. So in the update lives function, we don't want to keep creating and destroying the entities. That is why we created the table. So we'll check to see the number of lives, and only if it changes, then we'll turn off on or off the sprite. They'll still be there. We don't want to just keep killing and adding the entities. They'll still be there. And then we only have a max number of 5. So what we'll do is just shut it off so you can't see it. So since we added in the be hidden, we can do that now. So let's go and check. We go if self.m current lives is not equal to JADE-ite.num lives, like the current num lives, then we want to go in. We don't want to do anything otherwise. Okay, let's bring this up here. So now we just want to loop through all of our lives and then check to see if k is less than equal to the num lives. Then we want to set hidden to false. If it is, we want to set it hidden to true. So we go for k be in pairs self.m lives do, and we'll end that there. First thing, let's get the sprite local. We can actually, instead of doing the entity and the sprite get component, we can just create it all in one line because we're only getting the sprite here. So sprite is equal to entity at self.m lives at k. Because we're only holding the IDs in here. If you come here, we're putting the ID, so that's what we need. Then we want to get component, and that's our sprite component. Okay. So now that we have our sprite, we want to check to see if k is less than or equal to g data num lives. If that makes sense, then we want to not hide it, if that makes sense, okay? So we have our different lives and they're spread out from left to right. 0, 1, 2, 3, 4, etc. So if k is less than or equal to the num lives, we want it to be there. We want it to show. So k is where we put it in, okay? And if it's not, so if k is beyond the number of lives, we don't want to show that sprite. So we go sprite.beHidden is equal to false. Otherwise, we want to set this to true. So if k is bigger than that, than the actual number of lives, we actually want to hide the sprite, okay? And then right here, we want to check to see if it's game over. So if gdata dot num lives is equal to 0. I think 0.0 for some reason. We could probably do floor there. Self.m be game over is equal to true. Okay, and then we actually want to set the current lives, right here, to the num lives, to the gdata num lives. But I see we're getting the num lives a few times, so we can actually make that into a local variable. So local, and we'll just say num lives is equal to gdata num lives, and switch those out. Take this here and put this here, and also down here. And here we want to go self.m current lives is equal to num lives. Awesome. So that's our update lives function. So now we actually want to update the score. Okay, so we're going to need a way to update our score. And we don't always want to keep updating the score. So we're going to want to put in a check to see if the score has changed. And if it has, we'll update the score. If not, we'll just return. Okay, now did we add a score variable? We did. Okay, cool. So here, so we'll just add that in. We'll go function, and we'll say HUD update score. So we have our score function. We're going to want to say local current score is equal to gdata get score. And we're going to say if current score is equal to self.m score, then we're just going to return. Otherwise, we're going to have another function, and we're going to call it self.set score, and we're going to send in the current score. Okay, so let's go to that set score function here. So we'll say function HUD.setScore. And that just takes in the current score. And okay. So setting the score, we need to be able to change each digit. So we have to look at each digit because each digit is going to be a sprite. So let's look at our numbers here. Each digit is going to be a number. We're going to have this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the total amount of numbers that we can have for our score for each digit. So we're going to want to create a function that will get us the current value at that particular digit. We'll have 5 different digits, 10,000 being number 5, 4, 3, 2, down to 1. Okay, so if we're wanting to get the thousands, we're going to need to get the digit 4. So we'll get the value at digit 4, if that makes sense. We need to create a function to do that. So let's go into our utilities and add that in. So we'll just go right to the bottom here, and we'll add in a new function called getDigit. Now I'm calling the function getDigit. It should probably be called getValueAtDigit. So again, our highest score is 99,999. So that means we have a max of 5 digits. So in this getDigit function that we're creating, we will be getting a value back between 0 and 9. This value will be used to set our sprite UV's start X position. So if the value returned is 0, it'll be 0. So let's look at numbers again. So yeah, the getDigit will give us a value between 0 and 9, and that'll be based on our start sprite position. So if it's 0, it'll be here. So we'll move our start X over each time. So if it's 1, we'll move it to 1, 2, 3, 4, and so on. That's what it's going to be used for. So we can just say this. So function getDigit. That takes in the number and the digit that we want. Okay, so where it is. Is it digit 5, 4, etc. Okay, and then we're going to say local n is equal to 10 to the exponent digit, local n1 is equal to 10 to the exponent digit minus 1. Then we want to return math.floor, and we say num modulus n divided by n1. So this will give us the value at that digit. Okay, so we send a number in, we'll find where the digit is and get the value for that digit. Okay, so we need to use that. Let's go back into here into our set score. First thing we want to do is get our digit values. So get digit values, and then we want to say local 10,000 thousands, yeah, that would be better. Get digit at current score. Then we have 5 of these, so 2, 3, 4, 5, 10,000s, thousands, whoops, hundreds, tens, and ones. Okay, so now that we have our digit, we have the value at that digit for the current score. Now we can set the sprite UVs. So we want to set the sprite UVs. So we're going to have to get the local sprite. So we'll just say local sprite 1 is equal to entity at self.m 10,000 ID. Get component sprite. Okay, let's slide this down. And we're going to have to do this 5 times. So we'll actually do it all at once and change it accordingly. So sprite1 dot start x is equal to 10,000s. 10,000s. Then we want to change it accordingly. So we go sprite1 dot uvs dot u is equal to sprite 1 dot uvs dot uv width times sprite 1 dot start x. Let me just verify that we actually did it this way. Let's go to our sprite component. It looks like we didn't do the UV bindings either, so we need to do those as well. So let's say lua.new user type. We need to send in the UVs. All right, and we'll just call these UVs. And it's sol call constructor. And we'll use our sol factories. And this will just take in a float U, float V. That will return UVs dot U is equal to U dot V is equal to V. Cool, there's that. And then now we just have to add in our variables. So U, now taking the member, UVs, U. And we gotta go V with height. So UV height, UV height, UV width, UV width, and V. And then we have to come down here and add this in as well. So down here, UVs, sorry, we call them UVs. Cool, go back into our HUD, and that should work. So we're setting U to the width of the UV times the start X, because remember our UVs are between 0 and 1, and our width will be a number that's less than 1, and we want to move it over based on the start X. So now we got to copy these for the other 5. And then after we get to here, we want to set the score. So set the score. So we want to go self.m score is equal to the current score. Cool. All right. So we have set score, everything in there. So we'll have one more and it'll be the HUD reset. We need a reset function. Same idea for game over. So we'll say HUD reset. And here we're just going to want to set everything back to their default. So m.b game over is equal to false. Self.mb show false. Set the score to 0. Self.set score. We don't actually need that. We can just say self.m score is equal to 0. Now we want to hide the game over sprite, so we need to go, let's just say hide the game over sprite, and we can say local sprite is equal to entity dot self.m game over id get component sprite. Awesome. And we go sprite dot be hidden is equal to true. Okay, so we actually have one more that I forgot to do, and we want to set the number positions, like where are they going to be. So we need to add that in, and that'll only be called in the constructor. We are going to make a little function because it'll look cleaner in my opinion. So this dot set number positions. Cool. And let's make a little function for this. And we'll actually do that right here. So we'll say function HUD set number positions. And so what we're going to do is we're going to get the transform of the first one and then offset it each time. Local 10,000 is equal to entity. Actually, let's say local 10,000. Let's say 10,000 trans is equal to entity dot self dot m 10,000 id get component Actually, we'll just say transform 1. Transform 1. Yeah, get component, transform. And then we'll say transform 2, 3, 4, 5. 5, 4, 3, 2. And this is 1,000. M100. M10s. M1s. Okay. Let's go put a space here as well. It's driving me crazy. There we go. And we're just going to offset each position. So we'll say transform 2. Wait, we have to do it under 2, sorry. Transform 1 can stay. We don't need to change that one because that's our first one. Transform 2 dot position is equal to, oh, position dot x. I only care about the x position. Is equal to transform 1 dot position dot x plus 8 times transform dot scale dot x. So we want to move it over. So this is plus 8 times. So this is multiplying here. We want to move it over from this position, transform 1 position, times 8 or plus 8. So the width of each letter is actually only 8 pixels, and we want to also multiply it by its scale so it moves over correctly. So we can copy this and go down to transform 3 and change that. Let's transform 2 scale, or 2 scale, and this will be transform 3 scale, sorry. And then here, we want to change this to 2 and change this to 3. Okay, copy it again. Four. This is transform 3. This is 4. And one more time. This is 5. Transform 4. And transform 5. All right, so that should set the position for us. Now, there's nothing stopping this from being called again, but we're just going to play it on faith that we don't call it anywhere else. Now, we could just take this and shove it in there, but I think this looks a bit cleaner. Okay, we've done a lot and we haven't built anything, but we still have to add in our assets because we have a few new assets. We have to add those in. So in our asset defs, we have to add in our score. We have to add in our lives. We'll add in the lives first. So lives, and that's called just lives ship. And we'll have another one, game over, and that's just game over. Game over. Game over. Then we have the score, and that's just called score. And the numbers. Okay, I don't think I'm missing anything here. I think we're good. Now, we do have to now go back to our main here and add in our HUD. All right, so let's run it and see if it breaks. We might be forgetting something else, but let's just see what breaks. We also made a few changes to the actual engine itself. Now, we didn't add in the HUD yet. We do need to add that in, but let's just see if we have any errors first and deal with those errors. All right, there were some errors, but we had that score taking it away. So let's go back, go to our main. We're in the main. Let's get rid of this score. We don't need it anymore. Okay, and we might as well create the HUD while we're in main. It's going to be another global. So in main.lua, we just say g HUD is equal to HUD create. And down here, right after everything, we can just say g HUD update. All right, let's see what happens. And we got a bunch of errors. Okay, so entity defs, 174, let's go to that one first. Attempt to perform on global, window width. So it doesn't see the window width in our entity defs, probably because the way, so entity defs is up here. We probably could move our utilities up here. Let's see. It sees it then. Cool. So it saw it there. Basically what it's doing is it's going through these in order. And if you're trying to use something from something else, it needs to be seen before it's loaded. Okay. So what was our error? Let's run that again. So right here in our HUD 13, expect semicolon. That's funny. So 13. Yeah, semicolon. Yeah. That I work with C++ most of the time. All right. HUD 62. Let's go back there. HUD 62. Right here. Equals true. You guys probably already saw all these mistakes. Okay. HUD 70. Local. Don't know why I put that there. All right. It's showing the game over right now, but we got our lives, we got our score. Awesome. Let's see if the lives change. We'll get rid of the game over in a minute. If our entities, there they come. So yeah, our lives went away. All right, so we got an error when they updated the score. The lives are working though, and that's great. So let's see what the error is. Local digit, traceback 188, get digit, set score. Yeah, so we're not sending in the digit here. That's my bad. I was trying to go too fast. So 5, 4, 3, 2, 1. Okay. And let's see why our game over is not hidden. Let's go back to our HUD defs. So if not game over, else. Yeah, that's right. Okay. So let's go to our entity defs here. And where's our game over? Yeah. True, it should be hidden. Oh, yes. That's because we didn't do that in the load. So we go to our load entity in our utilities. Load entity here. So when we get our sprite, we also have to set it to hidden. So sprite.be hidden is equal to def.components.sprite.be hidden or false, because this may not be set. Okay, and let's try running it again. Awesome. So our game over is hidden. We got our score. Let's see if our score updates. Yes, our score is updating. We got our lives. Perfect. So that rotates a bit slow. I say we add in another button that can speed up our ship. If we get hit, we lose a life. Awesome. Cool. That's exactly what we want. So there's our HUD. Okay, so let's go into our ship real fast and add in another button to speed up our rotation. It won't be always, but it was just in case you wanted to go faster. So let's go into ship.lua. So we're in ship.lua, and right in our update function here, right below our forward, let's add in a local variable. So local, and we'll call it speed up, and we'll just set it to 1 at first, and we'll say if keyboard dot pressed, so if it's held, basically, and we're just going to set it to R shift, so right shift. Then I'm going to want to set it to 1.5, so speed up is equal to 1.5, and okay. And then we can add that in right here. So times speed up times speed up. So if we're not holding the button, it's just going to be normal. If we are, then it's going to be faster times speed up. Okay. All right, let's see if that works. See if we go faster. So normal, faster, normal, faster, normal, faster. Awesome. So we can spin faster that way. Shooting, our scores are going up. We're dying. All right. It's looking pretty good, looking pretty good. Okay, so now I want to add in an explosion. So if we get hit, you see how we go like a ghost, basically, like invincible for a while? Well, first, before we do the invincible, I want to add in an explosion. So that's what we're going to do right now. So I have an explosion sprite that I had. So I found this explosion here on Open Game Art, and I love it. It's perfect for what we want. However, the problem was the way that it's laid out. So I actually ended up changing it and making a new one, and I changed it into this, and I called it Ship Explosion. So I just put it in a straight line. It makes it easier for us to deal with. We don't have to worry about going up or down. We just go in one line and bang, that works for us. So we need to add that in, okay? So Ship Explosion, I need to add that into my assets. And then in our assets, we want to add in our explosion as well. And we'll just do this right at the bottom. And it's Ship Explosion. Ship Explosion. .png. And then here, same, Ship Explosion. That's what we'll call it. Explosion. Awesome. So now that we're going to need an animation now on our ship. So what we can do is go back into our entity defs here and go to our ship defs, projectile defs, and ship defs here. And let's add in an animation component. So let's say animation, and that is equal to new table. And num frames is equal to 0. Frame rate is equal to 0. We're starting everything off at 0 right now because we don't want it animating at all. And then we'll say frame offset equal to 0. Vertical is equal to false because when we do it, it's actually going horizontally. And then we say B looped is equal to false. We don't want it to loop. We only want it to do one. Then we have to go to our load entity and add in, I don't know if we added in animation, but we'll see. So sprite, transform sprite, circle collider, no. So we have to add in the animation. So if def.components.animation, then we need to add in a new animation component to our entity. So we say new entity, add component, and that's an animation. And let's go quickly look at our animation component to see how we did it. So we called it animation and we sent in num frames, frame rate, offset, vertical. Cool. So let's go back to our utilities. So it's num frames, so it's def.components.animation.num frames, then frame rate. And let's go back real fast. Frame offset, and if it's vertical or not. Frame offset and be vertical. Okay. Let's check our asset defs and make sure that's how we name them as well. Oh, just called it vertical. Should probably be vertical. Frame offset, frame rate. Cool. Looks like we didn't account for it being looped either. So let's go back into our animation component. And here we want to add that in. So let's go bool be looped as well. Oh, we don't even have that in there. So let's go into our animation component. We don't want it to be looped here. We want to be able to control if it goes one time through the animation or multiple times. So be looped, and it'll start out as false. So now that we have be looped here, add in be looped is equal to be looped. All right, and then just make sure that it's accessible. be looped. Be looped. Awesome. So be looped is last. So let's add that back in to our utilities here. Be vertical and be looped. Be looped. Let's change that to be vertical if we didn't. I can't remember. Let's take another look. Yeah. So let's say be vertical. Cool. All right. So now that we have that, let's just make sure it builds with no issues. And we have an error right here because it's trying to, so it's taking the modulus of 0 here. Well, we can't be doing that. So we got to fix this first in our animation system. There's actually another bug in here as well that I forgot that we have to fix. So right here in our animation system, we want to check to see if the animation .numFrames is less than or equal to 0. We just want to leave because it needs to have a number of frames or it can't really be an animation. Okay. Then we also want to check to see if we're not looped. So if we are not looped and the current frame is equal to the number of frames, we also want to skip. We don't want to keep looping it. Okay, so we go if not animation dot be looped and animation dot current frame is greater than or equal to animation dot numFrames minus 1. We also want to continue. And there's another problem as well. Because we're going to be checking to see, we need to actually add in a start time. So this needs to be, we need to add in a when did the animation start, or we're not going to get the correct frame. The correct current frame won't be right. So we need to fix this as well. So let's go into our animation component right here. And let's include SDL here. Include SDL.h. We need that because I need to add in a start time. And the start time is when the animation started. So we want to say static cast int get ticks maybe returns in, nope, returns uint32. Let's actually start a new line because this is getting too big, and we'll just say int start time. And then we say static cast SDL get ticks. Cool. And that'll give us our start time. So the start time will get the current ticks from SDL as soon as the animation component is created. Okay, and we also need to add that into our bindings as well. So here, and we'll say start time, and we'll just put it under current frame. Say start time. That's just animation component start time. So we get our start time. And we're going to have another function where we can reset when our start time actually started. So we'll go reset. That'll be our function. And we'll do a little lambda here. And it'll take in a animation component and animation component reference. And we'll just call it anim. And it's just a little one. And it'll say anim dot start time is equal to SDL get ticks. But before we do that, we will also set our current frame back to 0. So anim.currentFrame is equal to 0. Cool. So now we have something where we can reset it if it's looped. If it's not looped, we want to be able to reset it if needed. Okay. Now let's try to run that again. It should work now because now we're not dividing or getting the modulus of 0 or anything like that. All right, so we built, no errors, cool. What I wanted to see. Okay, so let's go back into our ship.lua. And we have to make some changes here. Okay, so up here, we have our be dead, and we have to have another one, and we need to call it be explode. So mb explode. That'll start it as false. And we'll come down here, and we'll check to see if it is exploding. So if self self.mb explode. Then we need a new function, and we'll call it self.update explosion. Okay, then come down here. And we actually want to change our check death function. So here, most of this is going to change for us. So what we're going to do now is push this down a bit and remove this here. Okay, the num lives can stay in there right here. We should probably get this as a local variable. So we'll say local num lives is equal to get num lives. Change that real quick. Probably use it in a few places. Okay, so then we want to say here also, and we're not exploding. We don't want to go in here if we're not exploding, and not self.mb explode. So if we're not exploding, now we want to set it to exploding. And we want to get the ship. So say local ship. Actually, let's take this here. So we need the sprite, and we also need the animation. So let's say local animation is equal to ship get component animation. Now we want to set our frames. So I know that this has 11 frames. So we go animation dot num frames is equal to 11. Animation frame rate, I want that to equal 15. Then not 150, 15. Then we want to set the current frame to 0 just in case it's not. Animation dot current frame is equal to 0. And then I want to reset it. So animation, actually we'll just reset it. We don't need to set it to 0 here. So we'll just say animation dot, actually it's a function, so we got to do the like that. Cool. Let's actually move our sprite down to here. Bring this here, move self explode up here. All right, now we have our sprite, so we'll change this to set animation, and we want to, whoops. Now we would need to actually change the sprite, so we have to go set sprite. So we want to go sprite dot texture name is equal to ship explosion. So that's what we called it. Ship explosion. Then we got to go sprite dot width is equal to 80. Sprite dot height is equal to 80. Then I want to generate the UVs. So sprite generate UVs. Awesome. So now I also want to set the transform so we can change the scale. Change scale or set scale. Cool. So we go local transform is equal to ship dot or ship get component transform. And now we want to set the scale. Okay. So we go transform dot scale is equal to vec2, and it's just 2 by 2. Okay. Set our lives, and here now we actually want to start the death timer. Death timer start. Cool. So we can leave that for the invincible timer. It could stay, but a few things have to change here, I believe. Nope, this actually looks good. Let's add reset box collider. All right. Create like ghost ship. So that's changing our alpha color. All right. So check death. All right. So we changed our check death, and I created this function called update explosion. So we need to actually create that now. So down here, we'll create a new function. We'll say function ship update explosion. And so in here, we want to check to see if we're exploding. So first we go mb explode. Are we exploding? And self.m death timer. We want to check to see if a second has passed. Last millisecond, 1,000. And this needs to be in an if. Sorry, guys. Okay, then we say local ship is equal to entity self.m entity ID. So we get the ship, and now we want to change the animation back. So local animation is equal to ship get component animation component. Okay. Now we want to check to see if animation dot current frame is greater or equal to the animation num frames minus 1. Then now we need to reset everything back. So first thing we'll do is reset the animations. Okay, so we go animation num frames is equal to 0. Frame rate is equal to 0. Current frame is equal to 0. Now we want to reset the sprite back to the ship. So local sprite ship get component sprite component. And we go sprite dot texture name is equal to ship. Sprite dot width is equal to 80. Sprite dot height is equal to 96. Sprite dot generate UVs. And we want to set the start X to 0 just in case it's not at 0, because the animation moves the X value. Now let's reset the scale. Or the transform. So local transform is equal to ship get component transform local scale. Oh wait, sorry, not local. So transform dot scale is equal to vec2 1 1. All right. So now we want to reset everything to do with the explosion and the death. So reset explosion. And we'll say self.mb explode is equal to false. Self.m death timer stop. And now we want to start the invincible timer. And then here we want to check to see if our num lives is equal to 0. So if d data num lives is equal to then and if not self.mb dead, then sprite dot be hidden is equal to true. So if we have no lives, we don't want to see the ship anymore. Okay, self.mb dead is equal to true. All right, and now that we did all that, we have to add in a reset function. So let's go function ship reset. And the ship reset, we're just going to reset everything. So we go self.mb explode is equal to false. Self.mb dead is equal to false. Self.m num lives is equal to JADE-ite num lives. Now this reset needs to be called after the data is reset back to defaults. Self.m death timer stop. Self.m invincible timer stop. Self.m cooldown timer stop if it's running. It probably isn't. And then we want to reset the box collider and colliding and all that stuff. So then we go reset the sprite and box collider. And that we just do local ship is equal to entity self.m entity ID. Then we go local sprite is equal to ship get component sprite component and set it back so we're not hiding and be hidden is equal to false. And now the box collider local box collider is equal to ship get component box collider. Oh, circle collider, sorry. Circle collider, not box collider. And then we'll say circle collider dot b colliding is equal to false. All right. I think that's it. I think we got everything. Now let's run it and see what mistakes we made. Okay, so it's running. Let's get hit by something. Boom, it exploded, but we got some errors. Okay, so in the update explosion, asteroids ship 152. Let's see what it's saying there, 152 here. Texture name is equal to ship. Ah, that'll do it. Try again. Oh, I don't like, the explosion didn't look right. Ah, yes, because we forgot to change in the animation system this here. We need to account for the start, for when we actually started our animation. So right here has to be STL get ticks now minus animation dot start time times our number of frames. Okay, that should work now. Let's run it. All right, let's explode. And perfect. Boom. So we're exploding. We're coming back invincible. We have our scores updating. Awesome. Game over shows up at the right time. We're not showing our lives. So now we want to be able to restart it. So right now, the only way to restart it is to actually restart the game. We don't want to do that. So let's go to our main.lua and just add something in to restart this. Okay. So we're updating everything right here. So we want to go, did we add in is game over for game data? Let's take a little look. So in game data here, so is game over, right? Num lives is equal to 0. Okay, so right here, let's go back into main. Let's not spawn an asteroid if it's game over. Let's move our HUD up here. and keep our spawn here, and we'll go if not G data is game over, then we'll spawn asteroids. So we won't just keep spawning them if it's game over. Else, so if it is game over, we want to check to see if keyboard dot just pressed, and then we'll say key enter. Then now we want to call all of our reset stuff that we had, that we created. Okay, so we want to go G data reset and G HUD reset and G ship reset. So all those are reset. Let's go to our utilities real fast. And did we make something to reset the asteroids? So down here, no, we didn't. We have remove, but we don't have any reset functions. So right here at the end of the asteroids, nope, yeah, this here. Let's add a little function in just to reset our asteroids table. So reset asteroids. So we start back anew, a fresh table. Okay, so we just want to go for KV in pairs asteroid do n, and we want to say local asteroid is equal to entity v dot m entity ID. Then we want to go asteroid kill. Then we want to say asteroids at k is equal to nil. So there's nothing in that position, okay? And we basically want to do the same thing for projectiles. So let's just copy this, bring it down to the bottom of our projectiles, and change it accordingly. So reset projectiles in our table, projectiles, projectile. So the same thing, v entity ID, projectile, projectiles at k equals nil. Okay, did I miss anything? I think I got it all. Okay, so let's add both of these in to our reset area. You can make this into its own little function if you like, or you can just do it as I'm doing it. Reset projectiles, tiles, cool. And let's run it. All right, so all I'm going for is, let's get a little bit of a score. Cool, so got a good score going. Let's get some explosions, awesome. And hit get game over. Wow, one more shot. Yeah, there we go. Game over. And then if I hit enter, okay, it didn't reset our score until we shot something. So we need to fix that. But it reset all of our other stuff, and that's what we wanted. Okay. Actually, that's exactly what we need to do. So let's go to our HUD.lua. And right here, we have the set score function. That's what we needed to do here. That's what I forgot. So self.setScore, and we set it to 0. That should work for us. And then it'll go through all this. It'll take in the current score and set all these values to 0. Awesome. Let's go. Let's get a little bit of a score. Oh, almost got hit there. I think I should change the cooldown timer so I shoot faster. But more of a challenge. Okay, so we got a bit of a score. We're exploding. It's resetting. Awesome. We should probably not be able to do this when we're dying, but that's all right. Okay, so when we hit enter, everything should reset. And it didn't. Cool. So right here, so field set score, 96. It didn't like that. Local num, 96. So it didn't like that. Right there. Silly me. All right. Let's one more time. Let's try again. Yeah, so I don't like that either, being able to move after we've been hit. So we need to add something in there. But now we can reset it. Awesome. So basically the whole game is done. So let's just go quickly fix that ship issue here in... Where is it? Right here. We want to return from this too. We only want to update explosion there. We don't want to do anything else. Okay, try again. I just want to see if it stops moving. And run. Yeah, you can't move until you're back. All right. Perfect. That's exactly what I want. One more explosion. One more die. Bam. Perfect. So that's it for the Asteroids game for that we're going to work on right now. But it is missing something. It's missing sound effects. So that's what we're going to be going into next. We're going to be going into creating a music player and a sound effects player using the SDL mixer. So we'll get into that in the next couple videos coming up. However, if you want to keep continuing with this little game here, you can add item drops and power-ups and stuff like that, and maybe make the window bigger and do some different changing. Play around with it. Have a good time with it. All right, take it easy.